Please open in your learning workbook to page 201. Let's do another example. Below is the graph of y equals log base 2 of x. Graph the function g of x equals negative 2 subtract log base 2 of x and give its domain in interval notation. Okay, so the first thing that I recommend that you do with a problem like this is rewrite the equation that was given to you. Instead of g of x equals, write y equals. And in this particular instance, notice that the subtract 2 is to the left of the log when we really think it should be to the right of the log instead. And so we're going to rewrite this as negative log base 2 of x subtract 2. Okay, great. So with those two things in place, now we can go ahead and move through solving this problem. It's the same parent function as it was in the previous problem. We've seen this several times now, so we're very familiar with this table of points. The only thing that's left to do is figure out what changed and where. What are our transformations? Okay, so let's follow our transformations order. The first thing we look for is horizontal shifting. That would be adding or subtracting inside close to x. We do not have that. There are no parentheses around this x subtract 2. So this subtract 2 is actually outside far from x. So we skip that step. The next thing we look for is stretching or shrinking. In other words, multiplication by a number. Well, there's no multiplication anywhere in here except for this minus, which is multiplication by -1, which is actually step 3, reflections. So this is outside far from x, it's multiplication by -1. So that part of our change is indicative of a vertical reflection. Vertical reflection. All right, and then finally, the last thing we look for is adding or subtracting outside far from x, which we see right here in this subtract 2. And so that is going to be a vertical shift. And because it's subtract, it's down 2. So the interesting thing about this is both of our transformations for this problem are vertical, and we have to do them in the correct order. We have to do the vertical reflection first, then we have to do the vertical shift. They both affect the y coordinates. With a vertical reflection, the y's get multiplied by -1. And then with a vertical shift down, the y's all subtract 2. All right, so we're going to take this table of points, we're going to adjust the y's, and that will give us our new table of points. The x's do not change. So 1, 2, 3, 4, 5 rows. Okay, the x's do not change, so there's still going to be 1/4, 1/2, 1, 2, and 4. But the y's are all going to change, and the way they're going to change is they get multiplied by -1 and then subtract 2. So change the sign and subtract 2. So this would be a positive 2 minus 2, which is 0. This would be a positive 1 minus 2, which is -1. This would be a -0, right, which is still just 0. Subtract 2, which is -2. This is -1 subtract 2, which is -3. And -2 subtract 2, which is -4. Remember, we're multiplying all of the y's by -1 first, then subtracting 2. So 2 times -1 is -2. Subtract 2 makes it -4. All right, now we're going to create our graph. Our y's are all non-positive, and our x's go all the way out to 4. So that means we're interested in quadrant 4 for this particular graph. So let's go ahead and do this. X's, 1, 2, 3, 4. Y's, -1, -2, -3, -4. Okay, let's plot our points. Here we go. So first 4, -4. That would be right here. Next, 2, -3, which would be here. 1, -2, which would be here. Half, comma, -1. Well, there's half for the x. And then we go down to a height of -1. Quarter 0, so that would be here. And then when we connect all the dots together, we get our logarithmic curve. All right, let's talk about the asymptote. We know that for our parent function, the asymptote is the y-axis. And we know that an asymptote is only going to change if somewhere in the problem there is horizontal shifting, shifting to the left or shifting to the right. Do we have any horizontal shifting in this problem? The answer is no. We have vertical, vertical, no horizontal, which means the asymptote does not move. It's in the same place. And so when we put that dashed green line directly on top of the y-axis, that completes our curve. Okay, the only thing left to do now is to find the domain in interval notation. So we can see here by looking at our logarithmic graph that we've got an arrow there and an arrow there. Let's see if we can figure out what direction the arrow is pointing. This arrow is pointing two directions, up and left. So which one of those things do we care about for domain? The answer is left. So left forever. But it's stopped by the asymptote. It can't get to forever to the left because of the asymptote. Where is the asymptote? 0. So my domain is 0, comma something. Then it goes forever to the right, so that would be infinity. So the domain in interval form is parenthesis 0, comma infinity, close parenthesis. We have our graph and we have our interval.